don't know how to say it.
Yeah, that's okay. But is there like a sort of just overall path or direction that you went in to solve this problem?
I
If
could
not, that's okay.
I could explain how I did it.
Hmm?
I could explain how I did it.
Yeah, sure.
Okay. So basically, if we were to get the smallest square that could fit a circle of a radius of 4, it would be 16. As if we did 4 times 4, we would get 16 from getting the area of the square.
Hmm. Yeah, that does make sense. However, I think it's a perfectly understandable mistake, but I think you confused radius with diameter in this case. So remember that in a circle,
Oh, wait.
yeah, yes, yeah, that's perfectly fine. But yeah, yeah, you're definitely in the right direction though. So radius would be this 4, and then we have a square that's like this. So you thought that you kind of confused it as like this kind of 4, right? So it looked like that. But yeah, so because the radius is 4, then we know that, let's just make this a bit more precise.
The diameter would be 8, so 8 times 8
Yeah, the
is
diameter would be
64.
8. So it'd be 8 times 8 equals 64. Yeah, but yeah, that was definitely pretty quick, and say that you were definitely on the right track there. So, does this make sense to everyone? So, if you want to explain it again, I can take like a circle like this, and if we put a square right around it, sort of like this, this is not the most accurate square, but then we would know that the square would be that because the circle has a radius of 4. So therefore, radius of 8, a diameter of 8, which will get translated onto the square. Okay, so let's move on to the next question, which is problem 8. So this question is, oh my gosh, let me move this. Okay. Walter gets up at 6:30 a.m., catches the school bus at 7:30 a.m., has 6 classes that last 50 minutes each, has 30 minutes for lunch, 2 hours additional time at school. He takes the bus home and arrives at 4 p.m. How many minutes has he spent on the bus? So does anyone have any ideas currently about what the answer for this is?
I believe that it's 60.
60?
Yeah.
Let me see. Seems like it would make sense. Yeah, Bella also thinks it's 60. So, I would say that the easiest way to do this problem is just to add it all together, right? 6:30, if we start at 6:30, catches the school bus at 7:30. Okay, so he starts at 7:30. Then we add 6 classes that have 50 minutes each, so it'd be 6 times 50. And then we add another 30 minutes for lunch and another 2 hours, which is just the same thing as 120 minutes. If we add that together, we will get 730 plus 300 minutes plus another 150 minutes, which is the same thing as 730 plus, let's see, so that would 300 minutes is the same thing as 5 hours. So, and 150 minutes is the same thing as 2 hours and 30 minutes. And adding these all together, we would get 3 p.m. So yeah, it does make sense. Yeah, it is Sorry, it is B because he finishes school at 3 p.m. and he takes the bus home to arrive at 4 p.m. So obviously, because he finishes school at 3, takes the bus home and arrives at 4, that means that there's a 1 hour difference, meaning that the answer is in fact 60 minutes since it was 1 hour. So does this make sense to everybody? How you sort of just add the minutes on top of the time. Yeah, time is a bit weird to think about especially because it's not in terms of 10, it's in terms of 12, but it's it isn't too complicated. You just add the minutes. And you have to be a bit careful with this. Yeah. Okay. So with problem 9, it's it's sort of just like this is kind of an interesting it's a lot more interesting of a problem here. So does anyone have any ideas for how to solve this question? So Zena says 1/12. Ricky says it's B. Do you guys have any ideas for, well, how to approach this kind of question? What sort of starting point should we go towards?
So I decided to I named them A, B, and C. I put A in the middle first and B to the left and C to the side.
So B to the left and C to the side,
Yeah.
like this.
And yeah, we could flip B and C to make another combination.
Mm-hmm.
So that would be two letters for two combinations for each letter that was in the middle. So if we multiplied that by 3, that would be 6. Oh, okay.
So basically what he is saying is that if we sort of isolate the middle section, then the two other sides, these two, there's two other possibilities. So if A is in the middle, there's two possible combinations which has A in the middle. So, and the same thing as for B. If we have B in the middle, there's two other possibilities for the other two letters, right? Because you can have A on the left, C on the right, or C on the left and A on the right. So yeah, I think this is a great way to think about this. It's a very sort of concrete way to think about it. Um, so in total, we would see that there are 6 different ways to line up the students. However, only one of these ways, A, B, C, is actually in alphabetical order. So it doesn't really matter which it doesn't really matter which like what names they have, as long we just know that there's a certain order out of these 6 which is the one that has alphabetical order, because there can only be one possible alphabetical order combination, as you can see here. So A, B, C. If we really want to go the extra mile, so just in case the answer is in fact C, so 1/6. But if we really want to go out the extra mile to find this, a really easy way to figure out how many combinations to arrange them are is just to do 3 factorial. 3 factorial just means 3 times 2 times 1, right? So if we have 2 factorial, it'll be 2 times 1. 4 factorial will be 4 times 3 times 2 times 1. And the way we use this is because it's actually exactly like the logic that's used right here. So this 3 represents all of the 3 different letters that we can put in the middle, and the 2 represents all of these top and bottoms, like this, top and the bottom ones. However, if we use factorials, we don't actually need to graph out every single combination. We can just use 3 factorial to figure out 3 times 2 times 1. Well, the times 1 doesn't really make sense here, but generally speaking, we just include a times 1 just so that it's including everything. But times 1 you don't really need to include, obviously, because it's the same number. But 3 times 2, and then if it's 4 students, we can actually just do 3 times 2 times, 4 times 3 times 2. We can get into like the specifics of why exactly this works for every single number later on, or maybe next class, but this is a very easy way, very fast way to think about this. Just do 3 times 2. When they're lining up in a line, there's 3 times 2 combinations of 3 students lining up in the line. Yeah. Okay, so this final question is a pretty interesting question, I will say. It is just finding the fraction of the square region that is shaded. So a really important thing to remember is the stripes or stripes are equal in length, and the figure is drawn to scale. Ricky says that it is B. So you want to give like sort of the idea what your thought process is for this? It also says that it is B. So let's take a look at this question real quick. So if we want to find the area, okay, it's very, very, very confident B. But mm, but the way we do this is, okay, the way that I would approach this is to just set this small square right here equal to 1. Okay, this is a really small square, but we set this equal to 1. The area of that small square is 1. And we know that the area of this sort of, let me change this to like red, I guess. You know, the area of this sort of section right here is going to be equal to, well, we can see that a bigger square like this would be equal to 4. So 4 minus 1 equals 3. Okay. And for this other black section, we can see that there's a big square like this that has an area of 4 times 4, so 16. And if we subtract 9 from that, which is the area of this smaller square right here, because 3 times 3 equals 9, we get 7. And on this biggest square, well, we know that this biggest square has each side length is 6, right? Because 1, 2, 3, 4, 5, 6. There's 6 different areas right here. You can, I guess I'll just use my mouse. 1, 2, 3, 4, 5, 6. And because of that, we know that this last one is going to be 6 times 6, which is 36, minus 5 times 5, which is 25. And that equals 11. So in the end, what we're going to get, combining, if we add all of these together, is going to be equal to 21. So the total area of the black sections are 21, if we assume that the smallest white square, it has an area of 1. However, what we're trying to find is sort of what fraction of the entire square is. And we know that the entire square is a 6 by 6 square. And 6 by 6, 6 times 6 equals 36. So the answer would be 21 out of 36. So 21 out of the 36 squares, because if we divide the entire thing into 36 squares, 21 out of the 36 squares on this big square are covered in black. Now you might notice that 21 over 36 isn't on the answer key. However, if we simplify this answer, So dividing both sides by 3, we get 7/12, which is an answer. So the answer in the end is actually C. Now, it is kind of tempting to look at the question and just say that it is B. I mean, 7/12 is pretty close to 1/2, but because the black ones are, each of the black pieces are slightly bigger than the corresponding white piece. So for instance, let's erase this. So for instance, this piece right here is slightly bigger than this piece right here. What? Okay. So this piece right here is slightly bigger than this piece right here. That means that, and each other black piece has a slightly smaller white piece corresponding to it. That means that there's actually a bit more black sections, black covered squares than white colored squares. And that explains why it is 7/12 instead of 1/2. So does this make sense to everyone? Give you a moment to think about it and how we can figure out this question. Okay, so now that we have all of these questions done, we'll move on to the next set of questions. So these are another 4 questions, and I'll give you a bit more time this time. I'll give you maybe around, we don't have too much time. So I'll give you maybe around 10 minutes to do these questions. So yeah, so have a shot. These are pretty hard questions. So we started a bit later on in the test this time so that we can get to some harder questions, more interesting questions. So really, really, these are pretty hard questions. But definitely give them a shot because they are hard, but it's just getting into the right mindset or getting into the right thought process, going in the right direction, and it's not too hard. Okay, so 10 minutes is up, so I think it should be enough time for most people to at least give each question a shot. So without further ado, let's move on to just doing question 11, problem 11. This problem is basically just define n as the number of whole number divisors of n in a rectangle as the whole number divisors of n. For example, 3 is 2 because 3 has 2 divisors. So find the value of 11 and 20. Okay, so basically the way we do this question is to simply just find out what 11 and 20 are in terms of their number of whole number divisors. So 11, okay, so Justin says C, Zion says A. Well, there's plenty of variance in opinion, but we don't have too much time, so I think I'll just take a look. So 11 has, well, 2, right? Has 2 different divisors. So has 11 and 1, right? 11 times 1 equals 11. There's really nothing else you can multiply, no other whole numbers you can multiply to find 11. It's a prime number, in fact. So, but with 20, we have, well, 20 and 1, but also 5, 4, and 2. So what this means is that we will get,
Forgot 10.
oh, sorry, yeah, you're right. I did forget 10. Okay, yeah, so that would be 10. And so that means that sort of square around 20 is just 6. And square around 11 is 2. Well, then what we get now is, what we need to find now is what the sort of rectangle around 6 times 2 is, which equals rectangle around 12. And, well, 12 has, well, 12 and 1. It also has 6, 2, 3, 4. So 12 actually has 6, which means that this equals 6. And yeah, so the people who said A were right. That's it's pretty good. So A is in fact the correct answer here. So this question isn't too there isn't really much of a trick you can do. You kind of just have to figure it out. You just have to do it. There's no trick with this one. Okay, so for problem 12, this is a geometry question. Okay, so Dana says D for this question, and Justin also says D. Okay, so there's plenty of people who say D in this question currently. And let's take a look. So this question is pretty simple. You just you take the idea that a triangle, all the angles in a triangle add up to A plus B plus C equals 180. And well, we see a triangle right here, right? 40, 70, and angle 1. So it means that angle 1 equals 180 minus 70 minus 40, which is just the same thing as 180 minus 110, which is 70 degrees. So however, we can also see that angle 1 plus angle 2 must also equal 180 degrees, right? Because they're all on a line, which means that 70 degrees plus angle 2 equals 180 degrees, which means that angle 2 equals 110 degrees. And we can now use the angle sum formula again to find that, well, angle 4 plus angle 3 plus 110 degrees, which is angle 2, equals 180. Which means that angle 4 plus angle 3 equals 70 degrees. And Well, we know that angle 3 equals angle 4, which means that angle 4 plus angle 4 equals 70 degrees. And what this means is that angle 4 equals 35 degrees. Yeah, so that was correct. It makes sense. And yeah, there are theorems, angle theorems that you can use to do this a lot faster, but I would say that honestly, it's not entirely necessary. You can do it by hand pretty easily as well. But yeah, seems like everyone did get this question. A lot of people got D. So yeah, makes sense. All right, so for problem 13, we'll take a look. 3 bags of jelly beans contain 26, 28, and 30 beans. The ratio of yellow beans to all beans in each of these bags are 50%, 25%, and 20%, respectively. So all 3 bags of candy are dumped into one bowl. Which of the following is closest to the ratio of yellow jelly beans to all beans in the bowl? Okay, so Ricky says E. Okay, so the way we figure this out is, I think the easiest way to figure this out is just to find the number of yellow jelly beans in total and then find the number of jelly beans in total. So the yellow jelly beans, yellow beans, the total beans ratio. And the way we do that is simply by, well, we have 26 times 50%. So half of the 26 bean bag, the 26 jelly bean bag is yellow. And 26, half of 26 is, well, 13. And 25% of the 28 bean one is going to be yellow, so that's 28 divided by 4, which is the same thing as 7, right? Because 25% is the same thing as 1/4. And finally, for 30, you can multiply that by 20%. So 20% of 30 is the same thing as a fifth of 30. So 30 divided by 5 equals 6. And now that we have this, if we add all of these together, 13 plus 7 plus 6, we get the total number of jelly beans, which is going to be 26. So 26 total yellow jelly beans. Yellow. However, if we want to find the total number of just any colored beans, then we just add the number of jelly beans in each bag. So 26 plus 28 plus 30. And this is kind of an annoying question, annoying arithmetic. So let's use a calculator real quick, which is just the same thing as 84. So total. So based on this, we can figure out that the ratio of yellow jelly beans to total jelly beans in all bags, if we dump them all together, is 26 over 84. So in order to convert this into percent, all we need to do is to just first of all, simplify it. And also remember that it's just the closest ratio. Simplify it, and we get 13 over 42. So based on this, we can see that 13 over 42 is going to be so basically an easy way to think about this is to just look at 13 times 3, right? So if a third of the jelly beans were if a third of the jelly beans were if a third of the jelly beans were yellow, then there would be 39 total jelly beans if the total number of yellow jelly beans stay the same. However, because there are 42, which is slightly more, that means that because if we divide 42 by 3, 42 over 3, then would equal 14. So if there were 14 total, if it was 14 out of 42, the ratio, then that would be 33%. However, because there's a bit less, that means that we know that it is not C, D, or E. And in order to figure out how much less, we can look at what the difference between 14 and 13 is. 14 and 13 is going to be a difference of 1, right? So what that means is that it's going to be 1/3 minus 1 over 42. And 1/3 minus 1 over 42. Well, what is 1 over 42 closest to? 1 over 42 is pretty close to 1 over 50, which is the same thing as 2%. So in the end, the answer that we're going to get is actually going to be 31%, because it's going to be kind of similar to, it's going to be about 33% minus 2%, which is around 31%. And if you really want to be sure, you can be sure based on the fact that 1 over 42 is actually slightly bigger than 2%. So because it's slightly bigger, then that means that we can be sure that even accounting for rounding error, it's gonna go even more down. It's gonna be even less than what we estimated here. Okay, so what this means is that, well, the answer is gonna be A. So this question is quite complicated because it first involves doing a quick probability question, but then it involves doing an estimate on what the percentage is. Because for most of these kinds of questions, they're kind of like far away estimates. So you kind of just look at the fraction. But for this one, you have to do a much closer analysis, a much closer sort of guess. And the easiest way to do these kinds of guesses with fractions is, as we did here, to look at a close fraction, such as 1/3, that we know what the percentage is, and then we look at the difference between that 1/3 and 13 over 42. And if we find that difference, then we can kind of easily round that difference, see about how big that difference is, and subtract or add that to our sort of estimated close benchmark. Okay, so this should be the last question. And this question is problem 14. So there is a set of 5 positive integers whose average or mean is 5, whose median is also 5, and whose mode is 8. What is the difference between the largest and smallest integers of this set? So has anyone figured out this question yet, or should we just begin? So okay, so first let's just remember what mean is. Oh, so Ricky says that is 5. Not exactly sure. Yeah, I haven't saw this question yet, but the best way to do this question is likely to just first start off with the mode. So since we know that there has to be at least 2 8s, right? Because, well, since there's 2 8s here, we know that there has to be 2 8s. Because if for 8 to be the most common number, there has to be at least 2. And we know that there has to be 2, because if there were 3, then it's not possible for the median to be 5 anymore. Because let's say that we put 1, 2, well, then the median will still be 8. So if we have 3 8s, then the median has to be 8. However, which means that we have 2 8s. And because the median has to be 5, well, then the center number, the third number, has to be 5 as well. And in order for the average or the mean to be 5, well, in order for the mean to be 5, well, then we need to get a number that is 2 numbers that balance out these 2 8s. So the easiest, like the most common way to think about this, like the quickest way, is to put 2 2s. However, this would destroy the only mode. So therefore, the difference is not actually 6. And in fact, what we have to do instead is to separate those twos. So I would say that the best way to do this is to do 1 and 3. So technically speaking, we could do 0 and 4. However, it says positive integers. So it has to be 1 and 3. And if you want to think about that, well, 2 plus 2, remember average is just adding all the numbers and dividing it by the total number of numbers. If we change it to 1 and 3, we don't change the total number of numbers. However, 1 plus 3 equals 2 plus 2, which means that they both equal 4. So that means that even if we change the 2 and 2 to 1 plus 1 and 3, then it's still the same mean. We don't change the mean. And if we really want to figure this out, if we really want to make sure, we can just add it together. 1 plus 3 plus 5 plus 8 over 5. Well, this equals 4 plus 5 equals 9. 9 plus 16 equals 25. So 25 over 5 equals 5. As such, 8 minus 1, which is going to be the difference between the smallest and largest and smallest integers, is going to be equal to 7. So therefore, the answer is, in fact, D. Okay, so does this make sense to everyone? Yeah, these questions are a lot harder than a lot of the other questions that we do normally, and are a bit more complicated, but say that they are definitely still doable. Okay, so since we don't have too much time left, you guys can take a look at this question, but yeah, but there isn't enough time to do the next question. So yeah, so that'll be it for today, and I want to thank you guys all for coming, and yeah, it's a pleasure. Goodbye. All right, thanks.